Okay, welcome back. So we are now going to do some examples in evaluating claims about the difference of two means, or just about the statement about two means from the two different populations, using samples, independent samples from the two populations. So in this first case, the first claim is a claim. We're testing a claim that says mu1 equals mu2. And we want to test this with a level of significance of 0.1. So what we have is we have two populations, okay? And in this case, we're assuming that their standard deviations are known. And then we take a sample of size 29 from the first population. We get a mean of 16. And then we take another sample of size 28 from the second population, and we get a mean of 14. And we want to test if this information actually, what does it say about the claim? All right. We're going to assume, because the sample size is less than 30 in both cases, we'll just assume that populations are normally distributed, and we're also going to assume that these samples are random, okay, and independent. So with that, let's see what our null hypothesis is. So our null hypothesis, well, because our claim has equality in it, this must be a null hypothesis. Okay, so our alternative hypothesis says mu1 is not equal to mu2. And this is our claim. Okay. All right. And as before, in this case, we are using a two-tailed test. Okay, because we have quality here. Okay, and we remember how this works, that these the combined shaded regions equals our lambda, our level of significance. So this is actually 0.05, and this is 0.05. Well, we'll get that is because we get 0.1 divided by 2 is 0.05. Okay, and we've sort of memorized this by now, but we can take inverse norm of 0.05, and we get negative 1.645, and this would be positive 1.645. Okay, so these will be our rejection regions, critical values, and now we compute our standardized test statistic z. Okay, x1 bar minus x2 bar is 16 minus 14. Okay, and we are assuming, like literally, mu1 minus mu2 is 0. So this is just minus 0. And then this is going to be the square root of 3.4 squared over 29 plus 1.5 squared over 28. Okay, make sure you do this carefully on your calculator. What I like to do is I compute this sum first, then I take the square root, then I take the reciprocal, and then I simply multiply by 16 minus 14, which of course is 2. And this turns out to be 2.89, and that's clearly in our rejection region, right? Way into our rejection region. So we reject null hypothesis. And that means we are rejecting our claim. So we say there's enough evidence to reject the claim. Okay. Let's look at the next example. Here, our claim has strict inequality in it, so we know that this has to be the alternative hypothesis. And then our null hypothesis, the opposite of this, mu1 is greater than or equal to mu2. And the alternative hypothesis is our claim. Okay. And so this says that, again, this says mu1 minus mu2 is less than 0. So unlikely differences would be negative. So we're using a left tail test. here. And that means this region is just single region here is equal to our level of significance, which is 0.05. And once again, we know this is negative 1.645. Okay. All right. By the way, we can check that our sample size are both greater than 30, so we can use the central limit theorem here. We'll also assume that these samples are independent and that they're random. And we can see the population standard deviations are given. So we go ahead and compute z here. So we have x1 bar minus x2 bar is 2425 minus 2432 minus, and then again this will be 0. We can assume that mu1 minus mu2 is 0. And then this is divided by the square root of 75 squared over 35 plus 105 squared over 90. Okay. And this is equal to negative 0.628, I think. And this is not in the rejection region, it's over here. So we don't reject H0. Okay? And because we're not rejecting the null hypothesis, we can't support the claim. So we say there's not enough evidence to support the claim. Okay. Hopefully we did our calculations correctly. All right. Do this calculate. Double check by doing this on your calculator. All right. The last example. Unfortunately, we have to do a lot of reading to figure this out. This is right from your book, and I omitted the first part was saying you're looking to buy a new washing machine, and there are two models, Model A and Model B. And a kind salesperson tells you that the mean repair costs for each model is equal. And you do your own research, and you show that you take a sample of the mean repair cost of 24 Model A washing machines, and you get that's $208, $208, and then you take a sample of 26 Model B washing machines, and their repair cost is $221. Somehow you're given that the standard deviation of, not your sample, but your populations is $18 and $22 respectively. Again, where sigma 1 represents the standard deviation of all the repair costs of all Model A washing machines. Okay, so actually instead of sigma 1, it could have really just said sigma A and sigma B. Doesn't matter as long as we understand that A, everything with an A comes from population 1, and everything with a B comes from population 2. That's all right. We can be very liberal with our subscripts as long as we're consistent. So the claim that we're evaluating is again one of equality, where mu A represents the mean repair cost of Model A, and this is the mean repair cost of B. Okay, so I should say we should have said that H0 says that mu A equals mu B, and the alternative hypothesis says mu A is not equal to mu B, and this is our claim that we're either going to reject or we're not going to reject. Okay. Now let's just write down the data that we've collected for our sample. We know that, first of all, we know that mu sigma A we said is 18, sigma B is 22. Our sample XA, our sample of Model A machines, what cost was 208. From our sample of Model B machines, that was 221. and the size of our first sample was 24, and the size of our second sample was 26. Okay. Alright, then we just have to plug well, first we'll find our rejection regions here. So once again, because our null hypothesis being saying two means are equal, we use a two-tailed test. Okay. And our level of significance is 0.01. Okay. So since alpha is 0.01, we divide that into 2, we get 0.005, and 0.005 here. And the inverse norm of 0.005 is negative 2.575. And this would be 2.575. Okay, we can use the inverse. We're getting used to seeing this number as well, but that's what we would have here. And so these are our rejection regions, and then we just go ahead and compute. So this would be 208 minus 221 minus 0 over the square root of 18 squared divided by 24 plus 22 squared divided by 26. Okay, we compute that. We get a negative number. We get negative 2.29. And while that's close, it's not quite close enough, right? It's not less than negative 2.5, right? 2.575. So we don't reject H0. So there's not enough evidence to to support or reject the claim. We're either going to reject or not reject the claim, right? So not enough evidence to reject the claim. Okay. Look at the examples in your book as well. Okay. Start doing the examples on the homework, and hopefully you'll get this. Practice, 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 and I'll see you next time.